Nika Valaru, and this is my lab report for Lab 1 in Physics 2212. So, the purpose of this lab is to observe how charged pieces of tape interact with other objects as well as with each other through a real-life experiment and a computational model. The models and principles involved are Newton's second law, the force due to gravity, electric field formula, electric force formula, and Coulomb's law. Assumptions and initial conditions include constant acceleration due to gravity of 9.8 meters per second squared with no air resistance, the tape length being 20 centimeters, the tape width being 1.9 centimeters, and the tape mass being 2 grams, the length scale of an atom being 1 angstrom and the area of an atom being 1 angstrom squared, and atoms completely covering the surface of the tape with no gaps. The materials were clear tape, a ruler, a plastic pen, objects for support, which were 2 books, a permanent marker for marking, and glow script. So here's a preview of the results. The tapes had a charge of 8.867 times 10 to the negative 9th coulombs. The ratio of number of electrons to atoms on the tape was 6.9 times 10 to the 6th. And as a note, I used multiple atoms in my model for the line charge. So the main ideas were about interactions done by electrons and charged objects. The system was tape B, and the surroundings were tape A, the earth, my hand, and pretty much everything else. So to set up the experiment, I created the tapes as directed in the instructions. So I cut pieces of tape that were about 20 centimeters in length. I folded over one end of all of them. I stuck one to the table as a base, and then I labeled the other 2 with U, and I used the base tape to charge the other 2. The first picture on the right was taken after the experiment was over, and then the second picture on the right shows how the tape was attracted to my hand. I used the 2 books to hang tape B. The tapes were attracted to everything except each other. They repelled each other. Because the tape was positively charged and it attracted the charged pen, that meant that the pen was negatively charged. So, to find the charge of the tape, with the free body diagram, we can see that there are only 2 charges acting on tape B, gravity and the electric force from tape A. With this information, I set the 2 equal to each other and solved for the charge of tape B, with the calculations being on the right. That's how I got 8.867 times 10 to the negative 9th coulombs. The force of gravity on a tape was found to be 0.00294 newtons, and the separation distance was found to be 0.019 meters. So, the number of atoms and the ratio. Using the charge of the tape, the number of electrons in the tape lost was found, the calculations being on the right, to be 5.54 times 10 to the 10th electrons. Using the information from earlier, the area of one side of the tape was found to be 0.0038 meters squared. Since the area of one atom is 1 times 10 to the negative 20th meter squared, the number of atoms on one side of the tape was found to be 3.8 times 10 to the 17th atoms. Therefore, the ratio of number of electrons to atoms on the tape is 6.9 times 10 to the 6th. So I started with the starter code in GlowScript. The biggest change I made was the depth for the electric field, which is shown on the right. In my model, I used 5 atoms on each side instead of just 1. This helped represent the system as a line instead of a point. The point charge version looked about the same, though there was only a single point. All calculated values, such as electric field, electric force, and gravitational force, had very similar values, though they were not exactly the same as compared to the in-person experiment. The gravitational force was slightly higher than the electric force. Similarities, the 2 forces were in opposite directions. Differences, the 2 forces did not have the same magnitude. Errors, the charge in the tape seemed to diminish over time. I may not have touched the tapes only at the ends, which could have skewed the results. The books may have had a charge, the tapes may not have been exactly 20 centimeters, and there may be some error in the code. So what if the charge of protons and electrons were swapped? The attractions and repulsions would be the same since opposite charges attract and like charges repel. However, some of the later calculations may differ because the negative charge is no longer in the sea of electrons, but rather in the nucleus. And compare the two values of the charge in a point charge model and a line charge model. They are different because the charge in the point is concentrated where the charge in the line is distributed, which changes the electric field and force. The line charge is more accurate because it better represents the shape of the object. Thank you for listening to my lab report.